So I'm pleased to be invited here today because my current role is with this organization called the Canadian Society for Unconventional Resources. I hear the mic going up. He's playing with this stuff. I don't really need a disclaimer. I'm used to being in the public energy sector, and I'm not now, so really you can't buy stock, you can't do anything. We're a non-profit organization. So we are, as I said, a non-profit organization formed predominantly by technical people in the oil and gas and other sectors. And our basic mission statement is to provide factual and collaborative information, specifically technical information, about what's happening on exploration development for Canada's massive unconventional hydrocarbon resources. We started this 10 years ago, the society, when a handful of us were in business developing something called coal bed methane. And we were all by our lonesome, and no one knew what we were doing. We probably didn't know what we were doing, but that was... And so we had basically a loose network of individuals. We've since morphed into more and more people, and has the world ever changed? What was our kind of unique expertise, being unconventional resource, is kind of the front and center stage of resource development in Canada and in North America. What's unique about our society is we are not an industry society. We have industry members. Matter of fact, about 50% of our membership is from both large and small exploration and production companies. So we have a lot of those people around the table. But we also have academic organizations, consulting firms, a lot of government agencies, service companies, IEA out of Europe, an in-kind member, financial companies, pipeline companies. So wide spectrum, and environmental companies, shouldn't forget that. Trevita, one of the biggest, is very active with us in a lot of things we do. So it's unique to have such a broad-based and diverse group, because it basically allows you to hear what everyone is interested in, get a feel for all the opinions and all the different points of view, and try to collaborate all that, and just try to properly determine how you go about running the organization to provide the wants and the needs of such a broad-based group. This is a little pie chart of our membership. So you can see, as you can see, the EMP sector is predominant, just under 50%, 44%, but a wide spectrum of other members. When I was trying to craft a message for today and make sure I did something that appealed to you for the AIA, which I'm quite familiar with, my son is a member, he's an Agrologists, he's a PAG, so he's in the environmental side of the business, and so I was chatting with him on that, and he said, try to spend time explaining how your industry and what you're doing as far as that could pertain to the environmental side. So I'm going to spend quite a bit of time towards the end of the talk on some stuff that we're very active in that I think is going to be very interesting to the audience. But this slide is about the current world, and that's the time is changing. Unconventional is now conventional. It is the major focus of North American oil and gas activity, bar none. It's been the recent development, and recent being less than 10 years, on a geological scale that's infinitesimal. But the development of unconventional resources only came to be because of the technologies of horizontal drilling, being able to stimulate horizontal wells, devising the technique of staged, or we call multi-stage hydraulic fracturing. So that horizontal wells now account for greater than 70% of the wells being drilled in North America. Over 95% in Saskatchewan and over 90% in British Columbia. So it is the game. It's accounting for over 50% of U.S. natural gas supply. It's a good and bad news story. We were so good that we hurt ourselves. But it's a free market working. We were able to develop a technology that liberated natural gas from rocks that we never thought were possible, and we've now made it possible to probably ensure hundreds of years of supply. When you have hundreds of years of supply, the commodity price drops. There's a good news side of the drop in natural gas prices. It ensures that we have a stable, as clean as we can get on a hydrocarbon basis fuel, and we have hundreds of years probably of production capability from that resource. However, because as I said, it depressed the prices, most of the industry now is turning their attention to the same techniques but applying them to oil reservoirs. Traditionally, a lot of the older oil reservoirs are being rejuvenated in Alberta, Saskatchewan, Manitoba, and British Columbia. So I want to cover over briefly what I'm talking about as far as unconventional. I think I've already covered a lot of the points. Where are they located in Canada and North America? How do we go about extracting them? How do we separate some of the myths from the facts? How do we regulate? And that's where I'm going to really preach to this audience, if you will. Preach is not the right word, but explain to you some really exciting things we're doing interfacing with the government of Alberta, the ERCB, Alberta Geological Society, on regulations that are being developed for unconventional and what that means to the environmental community. And it means big time. It's a big story. So unconventional, I've already touched on it. We've been able to extract hydrocarbons from rocks that previously were not capable of generating anything in commercial quantities. Those are basically rocks that we refer to as shale, very tight sands, tight carbonates, natural gas from coal, and also the development of gas hydrates that are coming in the horizon. And Japan just made a press release, I think about a week ago, on some experiments they're doing there. This is a massive resource that we're tapping now. Some of the terms I'm going to use, and I don't know how much background you have on geology, but I use the term reservoir. That's the rock that contains oil and gas. Porosity, that's the pore space between grains in a rock. That's where the hydrocarbons are stored. The permeability, for that term, that's the ability to connect those pores to extract the hydrocarbon. The devil word, hydraulic fracturing, that's the technology that we've developed. And Canada was pretty significant contributor to that technology, along with the US, to enable us to extract hydrocarbons from horizontal wells. And we use a process, as I mentioned, called multi-stage hydraulic fracturing. And then a new technology that's been employed over the last 3 to 4 years called microseismic, which really allows us to pinpoint what we're doing 2 miles under the ground. Nice little chart here on what we're talking about as far as the difference between unconventional and conventional. And it's all about permeability and, to a lesser extent, porosity. Conventional reservoirs had high porosity and high permeability. We've been able to shift the spectrum from good quality rock to really, really poor quality rock. Permeabilities of 0.1 millidarcies. That's literally almost tombstone. And we've been able to successfully extract commercial quantities of oil and gas from this stuff. I would never have believed that 10 years ago. Sidewalk cement, right in here. That's a good visual. Granite's kind of over here. So how the heck can we be that good? We're great. It's amazing. Triangular diagram, again, just showing the same thing. The first 50 years of the oil and gas business, we were concentrating on reservoirs fitting right in here. High quality, medium quality reservoirs, easier to develop, vertical well, complete the well would flow, and that was the major source of hydrocarbons for North America and for the world. With the diminishing supply of this type of reservoirs, industry got smart. We're an awful lot of technical and very smart individuals in the business, and we migrated down into figuring out how to extract hydrocarbons from this part of the triangle. And actually we've kind of lumped into, this is where we're heading, probably 100 years out, if we need to be. Where are the shale gas basins, if you will? Where's this activity happening in North America? It's massive. The thing with shales, that they're generally deposited in basins, and basins constitute the primary largest parts of the continent. In Alberta, Saskatchewan, and Manitoba, and into North Dakota, we were playing three main zones called the Montney, Duvernay, Cardium, Viking, Bakken. Massive resources. U.S. is playing the Marcellus Shale, Eagle Ford down here, Barnett, Woodford, Fayetteville shales. Massive deposits of shales out of very fine grained rocks. Just a blow up of what's going on in Canada. A lot of pipelines on this map. That's interesting. Again, the main play types in the Montney Formation in northeast BC has attracted a lot of attention. It's in the newspapers probably every second day. That's going to be the major resource supply for this baby right here, for the development of natural gas exports out of these tight reservoirs into the LNG facilities that are being contemplated off the west coast of British Columbia. That could never happen unless we had unlocked the value of about 1,300 trillion cubic feet of gas is what we're estimating to be in British Columbia right now. Staggering, just staggering amounts. This is just another diagram of that same type of thing I showed before, so I'm going to skip over it quickly. But just showing the, visually it's easy to see rock that has some holes in it, pores getting tighter and tighter and tighter. And we're over here now developing resources. So how do we extract oil and gas out of rock that's so tough? We do it three ways, or three different rocks. Organic black shales, you can see these are massive shales which virtually have no discernible characteristics. Black, massive, no bedding at all. This particular well has a, I don't know what this line came from, but it's the concept of inducing a very, if you will, a hairline fracture through that rock. If you could do that, and I'm talking about the diameter of a hair, it's not very big. If you could do that, these hydrocarbons will actually now be able to come out and fill up that hairline fracture and continually produce either gas or oil for a long time, 20, 30, 40 years. It just takes a hairline fracture because all this is saturated with hydrocarbons. It just could never move out of there before. If you have a rock that has more laminations of silts in between shales, then that fracture, that hairline fracture, might be a little bit more tortuous because it's seeing different beds, if you will, little lamination, but it still interconnects all that rock that's saturated with oil and gas. Some shales in some areas already have a lot of existing fractures. This would make a nice kitchen cabinet or kitchen tabletop, I think. So, as I said earlier, hydraulic fracturing is the key. Industry was able to develop a technique that could isolate a small portion of a horizontal well, pump fluid with some sand into that area of the well bore, create these micro fractures, and they're very small. They're almost like a spider web. We've seen rock that we've penetrated back after we've done one of these frac jobs. And it's like a little dendritic fracturing. It's not big holes. They're almost hard to see at the naked eye, just like a little dendritic pattern of fracturing that happens. And it doesn't go very far, usually 20, 30 meters away from the well that we're doing it, but it's just enough that it allows a little conduit for all the oil and gas to get into over time. If we didn't pump sand with that fracture, those little micro pores that we're creating, micro fractures we're creating, would seal back up again. So we use this natural sand that you would find. It has to be very clean, but we use that with the slurry that we're pumping into the well to keep the fractures open. But we're talking microscopic. A sand grain is keeping that fracture open. And if the fracture is kept open, we're able to pump back the fluid after we release the pressure. Of course, the reservoir that might be 2 miles underground is at much higher pressure than the ground, which is only 14.7 psi per square foot. So that will naturally allow the hydrocarbons to want to flow up to the surface. That's kind of real basic hydraulic fracturing. Here's a neat diagram that kind of summarizes that. 1 to 2 miles down, and I think most of the reservoirs that we're chasing in Western Canada are at least 2 miles deep, by and large. We drill a horizontal well through a shale that's possibly, like I said, 1,500 meters down, 2,000 meters down. And we start at the very toe of the well, the end of the well, we propagate a small little micro fracture there. We move back, do it again. We do it in stages. And it was that technology that allowed us to isolate this part first and do that little stage that allowed this to work. We could never do that if you tried to put any pressure on the whole rock. It would just disperse the pressure too much, and you'd never be able to concentrate enough to create this little dendritic pattern of hairline fractures. Now the part that I think that's going to be really interesting to this audience is the regulation and how we're moving in this new technology to try to look at the issues we're facing, because anytime you develop something that's not done 10 years ago, you have to make sure that as you try different things, and this applies to what I heard with Cenovus, we're all developing things that we find out through the process. And that is that, you know, we had current regulations in Alberta, British Columbia, Saskatchewan, and Manitoba. Those have long histories of oil and gas development. So they had history and regulations in place for drilling a well. They had regulations in place for what testing can be done, how much data we had to accumulate and provide to the government. We could request, you know, on average, a 1-year confidentiality period if it was ultra-sensitive data, 30 days if it wasn't, but basically allowing, you know, certain window of opportunity for the operator to have his confidential information kept confidential. But after a year, it goes out to everyone. And we had very specific regulations on hydraulic fracturing. We did hydraulic fracturing, and we've done that for over 50 years. It's just that it was done predominantly in vertical wellbores. We didn't do anything different. It's just that we applied that technology into a horizontal well. So when we're starting to talk about doing multi-stage, so we're actually stimulating a well that's now 1 mile long on average, let's say as an example, you have to ensure that the regulations basically are consistent with that kind of development versus a vertical well. But by and large, we're governed by the same rules and regulations on surface casing, production casing, cement, bond logs, etc. And here's a diagram of those kind of, the idea of a regulation that was in place for a vertical well. If you're drilling a well through the shallow defined aquifer area, an area that has a shallow water aquifer, you must run at least 2 barriers to seal off against that aquifer. Conductor pipe, barrier 1, surface casing, barrier 2, and then intermediate production, barrier 3. And each one of those layers of steel and cement have to be run down to at least the bottom of what we call the base of groundwater protection. Then we went ahead and conducted our operations in the vertical well. We've now taken that same technology and applied it to the horizontal. So everything that happens up here is exactly the same, except at this point the well makes a turn. But everything up here for the first 150 to 300 meters is exactly the same as what we did for 50 years. Good little diagram of, it's always good to visualize things. People don't see this stuff. I'm used to it, but you may not be. And that's a diagram of the surface casing in a well, the cement that's run after the surface casing is set. The second liner we call intermediate, also another layer of cement, and then the third string of steel being production casing. So you have steel, cement, steel, cement, steel before you get to the rock. 3 layers of safety. So, what's happening with new regulations and how does it impact changes to our environmental protection and the plans going forward? In December of last year, the ERCB released a draft directive to industry, to stakeholders, to everyone, on the proposed regulations to regulate hydraulic fracturing, specifically under the context of horizontal drilling. In other words, it was something that we need to apply as an extra layer of safety and security for horizontal that was not in the existing regulations. Specifically, they wanted to address the following issues. We do not want to lose well integrity. There must be a dual barrier system. I've already shown you that a lot of wells, it's actually a 3-layer system, but 2 is the minimum. Another key point, reduce the risk of communicating to another well. We call that inter-wellbore communication. In order to do this, the government said, we want to see a plan that determines risk assessment and risk management prior to you undertaking a fracture operation. We do not want to see something happen in a wellbore nearby that you didn't plan for. And we want to see a plan, and I'm going to get to that. We want you to maintain control of all wells within a certain radius of where you're doing your operations. And part of the reason for that is we're developing old pools, or I guess the best word is rejuvenating. We're going into old pools and going to the edges of those old pools, which were never commercially productive, but with this new technology, we can make them commercially productive. The trouble is, there's a lot of old wells around those old pools, and you can't have anything bad happen to those old wells. Prevent impact to non-saline potable aquifers. Stringent requirements are going to be put in place if you are anywhere close to 100 meters within the base of groundwater. And last, prevent surface impacts. For example, cannot conduct hydraulic fracturing operations within 100 meters of bedrock. So this is what the government was saying to us. This is what we're thinking. This is what we want to go towards. And we've given them a lot of our comments on that. And here's, then in January of this year, they asked for industry's comments, stakeholders' comments, anyone, because it goes out to all interested parties, and they want us to respond by, actually this Friday, Good Friday, on a paper they have, a discussion paper called Regulations for Unconventional Oil and Gas. Very comprehensive document. And I think the AIA has probably looked at that. If they haven't, they certainly should have, because there's a lot of stuff in there that would be very applicable to the environmental organizations in this industry. And that's basically a shift to what they call play-based regulation. You don't go in and unconventional and drill usually a single well. You're planning on going in there and drilling 3 wells, 5 wells, 10 wells. It's massive, the amount of development that you're going to do. But you have to control the surface impact, you have to control a lot of factors. So they said, because we know you're doing more comprehensive projects, we want a play development plan. So you see the commonality between what I said earlier, a risk assessment and risk management plan. Now it's a play development plan. And these are 2 impending regulations, but they're coming. This is hot off the press. But that play development plan must address water management. An operator does not go in there and drill a well anymore and just get a well license. I want to see your plan on water management. How are you going to protect and efficiently utilize water resources? What are you going to use in your frac operation? How much are you going to flow back? How are you going to recycle it? What your demand is going to be for fresh water or for saline water? Where are you going to get it? Comprehensive water management plan. Surface infrastructure development plan. How are you going to ensure you minimize disturbance for all aspects of the operation? These are comprehensive documents. I'm dying to see how industry is going to get their head around doing the first one, because they've never really done it. But I guess they've done parts of it, but now they've got to put it all together. Subsurface reservoir management. That's easy. That's what I'm used to seeing. Why are we drilling this well? What do we expect to get as far as ultimate recovery? Why are we maximizing recovery efficiency? Managing the reservoir. But that's only one item. Stakeholder engagement. You don't do anything unless it's open, transparent, and you have buy-in by the community. Life cycle wellbore integrity. You must pressure test all wells in your area, all wells adjacent to your area. Massive changes to the regulations, and I think in a very positive way. So here's my pitch to you. Take a look at this. That's your business. There is a tremendous demand going to come to people on the environmental side, because these regulations are really focused on water management, waste management, air quality, orderly development, safety. I guess health, safety, and environment is always usually in departments. Information and advice, well, that's stakeholder engagement. Again, probably with people with this knowledge are going to have to be present in those stakeholder meetings explaining what the industry is doing. Pool geologist only gets 1/6 of the time now. I think this is massive. This is a massive change. It just ensures a good industry, a good practice for everyone, and we're saying we're trying to cover off every possible situation that may occur through 20, 30, or 50 years of development. So, to summarize, ERCB, in its draft directive on hydraulic fracturing and its discussion paper on regulating unconventional resources, is moving towards a large-scale, play-focused set of regulations. Big plans. Not just, I need a well license, let me drill a well. The shift in regulatory approach places a major emphasis on project-scale environmental issues and outcomes. It's all over the documents. There will be a significant demand for experienced environmental professionals. I told my son, you've got a job for life. Because you need to be able to assist oil and gas companies in putting these documents together. And most of the big guys have that staff. You saw Cenovus, they have that staff. But the small guys who do a lot of drilling, I used to come from that universe, we couldn't hire those guys. We hired firms. We hired a lot of little firms. And almost all those firms that we were hiring were PAGs. So the EIA certainly represents a lot of these environmental professionals, and I believe should play a significant role with industry in working on this new regulatory environment. A little plug before I let you go. The bar is almost open. One of the things at CSUR we're working on right now, believe it or not, is an environmental innovations guidebook. We're teaming up with June Warren Nichols Publications, who does Oil Week magazine, Inquirer, Daily Oil Bulletin, Canadian Heavy Oil Association, ourselves, 2 nonprofit organizations, and then Alberta government. On draft, I'm putting together an environmental innovations guidebook, directory. I encourage, if you're in that field, that you contact someone, get your name in the directory. It's free. This is going to go worldwide. We're going to try to showcase, our intent, showcase the environmental performance of Canada to the world. And Alberta government is really spending a lot of time and effort talking to other jurisdictions in North America that don't have unconventional resource development, don't know about these issues. We're comfortable with them in Alberta because we've dealt with them forever, but I tell you, once you leave our boundaries, they don't know what we're talking about. So welcome you to take a look at that and become involved in that initiative, because it's really the way our society and our industry is heading. Thank you.